Hi, and welcome to day 5 of Quadratics. Today we are graphing quadratic equations. In an effort to save some time, I'm going to do all the charts for your graphing without showing you how to use the graphing calculator. I'm assuming most of you know how to use that, and if not, I will show you how to do that in the actual classroom. So we will be using a graphing calculator to graph quadratic equations. You must first get y by itself if it's not, and then type the equation into the y equals on the calculator. Then hit second graph to get your table, and look for the pattern and record your x and y values in a t-chart. So I put in y equals x squared plus 4x plus 9 into my calculator, and I got this from my chart. So I have my x and my y, and it's -5, -4, -3, -2, -1, 0, and 1. And those are my 7 points. This is 14, 9, 6, 5, 6, 9, and 14. So then I need to come over to my graph and plot my points. I already drew my x and y axes on, and I labeled them. So -5, 14 is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then -4, 9. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then -3, 6. And then -2, 5. Then -1, 6. And 0, 9. And 1, 14. Once I get all my points on my graph, then, to the best of my ability, I draw a smooth curve through all of my points. Okay, I missed a few points. This is a little bit harder without using a regular pen. Sorry about that. And I label my graph y equals x squared plus 4x plus 9. Now I know you think, oh, I should be done. But we're going to do a little something extra here. I want you to find the discriminant of this equation. And remember, the discriminant is d equals b squared minus 4ac. So in this case, b squared, b is 4, so 4 squared is 16, minus 4 times a is 1, and c was 9. So I have 16. -4 times 1 times 9 is minus 36. So 16 minus 36 is -20. So my discriminant is -20. If my discriminant is negative, okay, and in this case, that is constant. So the entire graph is above the x-axis. And that comes out of my discriminant chart. And if you look at my graph, it works. If I have imaginary roots, it never crosses the x-axis. across the x-axis. Okay? I have this point here, which is known as my vertex. And in this case, it's a minimum. The vertex is also known as the turning point. If you look on the graph, it's the only one that doesn't repeat. So again, this is the vertex or a turning point. Okay? Moving on to the next one. All right, here we have y equals 2x squared plus 4x plus 1. So when I type it into the calculator, this is what I get. -4, -3, -2, -1, 0, 1, and 2 has values. I have 17, 7, 1, -1, 1, 7, and 17. Then I need to go over to my graph. It doesn't really matter where I place my x-axis because pretty 11 is pretty even on both sides here. So that's my y-axis. Sorry, I meant my y-axis, not my x-axis. My x-axis needs to be pretty close to the bottom. Otherwise, I'm not going to get all of my points on the graph. And if that happens and you don't get all your points on the graph, it's not a big deal. Just graph what you can. That's my x-axis. See if I can change my color here, if it'll let me. Nope. Let's see, red. So if I'm going to go and plot my points, I have -4. Nope, it's not going to change for me. Oh well, 17. Which is way up there. And then -3, 7. Well, that's funny. And then -2, 1. And then -1, -1. 0, 1. And then 1, 7. That worked out better this time. And 2, 17. Again, do your best to connect all the points with a smooth curve. We do not use a straight edge while we are graphing parabolas except to draw the axes. Don't forget to label your graph as y equals 2x squared plus 4x plus 1. And this time, my vertex is a minimum again because it's down the bottom. And if I look at my chart, my minimum is right here because my y values do not repeat. And to find the discriminant again, b squared, b is 4, so it's 16, minus 4 times a is 2, and c is 1. So I'll have 16 minus 8, which is 8. 8 is a rational number, so my roots are going to be real. Sorry, it's not a rational number, it's a real number. It's an irrational number because it's not a perfect square. And unequal. So if you look here on the graph, this is a root and this is a root, and they're not the same. Therefore, I have two roots. Okay, and when we have this, it touches the graph at two places that are fractions or decimals. Okay. So that's it for that graph. Okay, circle the vertex up there. All right, for the next problem, x and y, and this one's going to go from -5 to 1. So -5, -4, -3, -2, -1, 0, and 1. And my y values are -7, -2, 1, 2, 1, -2, -7. Now when I go to draw these axes on, again, my y-axis doesn't really matter. And this time I need to draw my x-axis so that I have plenty of room below it, because my y values are more negative. Okay, in order to save some time, I just graphed that for you. My vertex, my turning point, is at -2, 2, and this time it's at the maximum point. Make sure you're labeling your graphs. And to find the discriminant here, b is -4, so -4 squared is 16, minus 4 times a is -1 times c is -2. So it becomes 16, minus 8, not plus. And I get 8, which means I have the same as above. And my graph follows true. I have two different roots. They are not exactly on points or on, the grid, therefore they are fractions or decimals. And the reason that this one opens down is because a is negative. And remember we said if a is negative, it opens down. All right, so that is graphing. I will work with you with the calculators in class tomorrow.